It's going to be a video of me doing some of the homework problems assigned to you from section 8.3. You were assigned about 12 problems, and I'm going to do about half of them, so I'm going to do 6. I'm going to do problems number 10, 14, 18, 30, 34, and 38. I will start with problem number 10. So problem number 10, you have a fraction, specifically 4 over 3, all taken to the power of -3. So this is similar to problems we've done in the past. You have an external exponent of a -3, and you have a pair of bases, specifically the base 4 and the base 3, and each of those have powers of their own. They're hidden right now. They're not written, but they are powers of 1. So what you do is you multiply the external exponent by the internal exponent, so the -3 times 1, and then -3 times 1 again. And that gives us 4 to the -3rd over 3 to the -3rd. Now we just learned that in order to make a negative exponent into a positive exponent, and we have to do that to get our answer correct, we have to take the reciprocal. In other words, we have to flip whatever we try to change the sign of. So in this case, we're going to have to flip the 4 to the -3rd. It's in the numerator, it's going to go into the denominator. So this is going to take a trip down. At the same time, the 3 to the -3rd is in the denominator, and we're going to flip it to the numerator. They're going to swap. They don't always have to swap, but they both have negative exponents, so they both have to make a trip. So we're going to have 3 to the 3rd, so 3 to the -3rd came up, and at the same time the exponent switched from negative to positive, and down here now we have 4 to the 3rd. We're almost finished. Now we just have to simplify, so it's going to be 27 at the top, and on the bottom we're going to have a 64. 4 times 4 is 60. Yep, that's about it. So that's the problem. Number 14. 14 we have, oh, this is very simple. We have 3 to the -2 multiplied by a 2. Power to the power problem, external and internal exponents, just multiply them. -2 times 2, which is going to be 3 to the -4. Again, to make a negative exponent into a positive exponent, we have to take the reciprocal, which we have to flip it. It's in the numerator now. It's going to go into the denominator, because remember, we can always write it as over 1. That's it. The only thing left to do is simplify it, and that's going to be 1 over 81. And that's the answer to number 14. Number 18. 6 to the -3rd over 6 to the -5th. Two ways of doing this problem. Either way is going to be correct. You can either do what we did in problem number 10, flip them first and then take care of the exponents. We can take care of the exponents and then flip it. Doesn't really matter which way you want to go. I'll do them both ways. So this is going to be way 1. This is going to be way 2. Way 1 is flip them first. So the 6 to the -3rd is going to go to the denominator and turn the exponent positive, and the 6 to the -5th is going to go to the numerator, turning the exponent positive. So literally they just flip-flopped, and the exponent turned positive in the process. And then it's a quotient of powers. Two of the same base are being divided. You just subtract the exponents. 5 minus 3, which is 6 to the 2nd power, which is 36. Now you could have also done the quotient of powers first. You could have said, well, two of the same base being divided, so you subtract the exponents. Same thing as -3 minus a -5. So -3 minus a -5, which means it's -3 plus 5, which is 6 to the -2. And again, to turn in order for us to turn this particular problem into a positive, we have to flip this. Hold on a second, something went wrong. Negative 3. One over. It's going to remain in the denominator. And if you want to flip it to make it positive, you can most definitely do that. Which means it's going to go up. It's going to go up. So that's going to be 6 to the second power, which is 36. Same answer, regardless of which method you used. I think the first method was easier. Flip and then do your calculation. Almost every case, I recommend flip first, then do whatever math is attached to it, as opposed to doing the math and then do the flip, because then you do end up confusing yourself on where you should the fraction be on, should the work be done on the denominator and the numerator. So to avoid the confusion, flip first, then do the work. In every case, it's going to save you some troubles later on. That was 18. Now we're going to do number 30. We have 6x to the negative 2. And y to the third. Everything taken to the negative third. So as a power to the power problem, multiply the external exponent by the internal exponent. So this is going to get multiplied by this, and by that hidden 1 right there. So we're going to get 6 to the negative third, x to the positive, because negative 2 times negative 3 is going to be a positive 6, and y to the negative 9th power. Now we have 2 of the bases have negative exponents. One of the base has a positive exponent. So x to the 6th is fine where it is. It doesn't have to go anywhere. The other 2, on the other hand, have to flip. So they're going to go on the bottom. So their exponents can become positive, which gives us x to the 6th still on top, then 6 to the 3rd in the bottom, and y to the 9th on the bottom. We don't have to fully evaluate this because it doesn't ask us to simplify it, just asks us to leave an exponential form, so we're going to keep it as that. You just have to write down that y is not equal to 0, because you can't have y being a 0. And that's it. That's this problem as far as the book is concerned. The only thing you could have done extra is to simplify the 6 to the 3rd, which is 6 times 6 times 6. So that's 30. 34 next. 34 is 1 over 8x minus 2. Or sorry, 8x to the negative 2nd power times y to the negative 6th power. So again, you have 3 bases. The 8 is to the positive 1st power. It's a positive exponent, so that doesn't have to do anything there. It's going to stay where it is. These 2 don't have negative exponents, so they are going to come up. And as they do this, they are going to make their exponents positive. So we're going to get x squared times y to the 6th all over 8 to the 1st, but we don't have to write that. That's it. That's all there is to it. You don't have to write any kind of a statement of not being equal to 0, because the only thing we have in the denominator is an 8, and 8 can't be a 0. So, wasn't that a simple problem? And the last one, this is the last problem on your homework. It's going to be 38. And this one's a little bit tougher. They always like to save the best for last. So 3x all to the negative 3rd power times y to the 4th power all over negative x squared times y to the negative 6th power. Alright, so again, first of all, I gotta do this distribution here. It's a power to the power, distribute the external exponent to the hidden ones for both of those bases, which is going to give me 3 to the negative third, x to the negative third, y to the fourth, negative x to the second, y to the negative sixth. That's multiplication there. Take a look at all your negative exponents. This one, and this one. Anything negative has to flip. Now, this is not a negative exponent. This is a negative x to the second power. It's a negative base. Negative bases are just fine. Only negative exponents have to be dealt with. So the negative x to the second power stays where it is. The y to the negative 6th power is going to move. The 3 to the negative 3rd power is going to move. The x to the negative 3rd power is going to move. So this is going to come up. This is going to come down. This is going to come down. So, and in doing so, they change their signs from negative to positive. We're going to have over here y to the 4th times y to the 6th, so that and that. On the bottom we have that negative x to the 2nd times 3 to the 3rd times x to the 3rd. Alright, good. So the only thing left for us to do is some simplifications. First of all, product of powers up top. You just add the exponent, 4 plus 6, that's y to the positive 10. On the bottom you have x and x, so the same base, product of powers, add the exponents, 2 plus 3, that's 5. It's still going to be negative, so negative. And then 3 to the 3rd power, that's 27. So I want to write that first. You write the numbers first. Negative 27 x to the 5th power. And that's about it. The only thing you could do is migrate this negative to the middle, because that's how we typically like to write it. Negative 27 x to the 5th power. And right over here, x is not equal to 0, because the x is in the denominator and the variable you have to specify. So technically that's, whoa, sorry, that's no longer negative. Yeah. So minus that. So that's the final answer. Negative the whole fraction y to the 10th over 27x to the 5th, and x cannot equal to a 0. Again, the reason this negative on the bottom, I just usually we write it in the middle if possible, though you could have, this could have been your answer just fine. Probably would have been less messy too. So that can be your answer just fine as well. So let's just forget this. Yeah, there we go. That's your answer. Alright, so there we go. Those were the 6 problems worked out. If you need any more help, come by before school, after school, or during lunch, and I'll be more than happy to help you out. Thank you very much. Have a nice day.